Okay, this is examples of what to do if you're simplifying a square root and there's already a number out in front of the square root. I still want to go through my steps of figuring out factors for my perfect squares. So for 125, I could break this down as 3 times the square root of something times the square root of something. 125 can be broken down into 25 and 5. I'm not sure what else you would use, so I'll stick with 25 and 5. I still go through the step of simplifying my perfect square. 25 is a perfect square. So I'm going to have 3 times 5 times the square root of 5. So the only thing I did there was simplify the perfect square. And notice we have the multiplication dots. So we are just multiplying all these things together. So 3 times 5 becomes 15. And then I have a square root of 5 left over, and that's my final answer. 15 times the square root of 5. Or you could just write that without the dot, 15 root 5 if you wanted. For the second one, I have negative 5 times the square root of 48. And 48, if I start off with, I could say is 2 times 24. Neither one of those are perfect squares. I could try 3 times 16. And that actually works really well because 16 is a perfect square. If I would have done something like 4 and 12, 4 would have been a perfect square, but not as good of one to use as 16. So let's do that. We're going to say negative 5 times square root of 3 times square root of 16. Notice I'm putting my perfect squares on this page in blue, so it's easier to keep track with what's going on. We have negative 5 times the square root of 3. The 3 doesn't change because it's not simplifying. The square root of 16 does simplify to the number 4. So negative 5 times the square root of 3 times 4. Or I have negative 5 times 4 times the square root of 3, because multiplication is commutative, which means you can change the order in which you multiply problems. Negative 5 times 4 is negative 20. The square root of 3 does not change, and so that's my final answer. So if there's an integer in front of a square root, the strategy is to still work with the square root the same way, and at the end of the problem, you'll need to multiply your simplified integer up front by the integer you started with, so negative 5 times 4.